Welcome to The Explainer. So, have you ever wondered how Netflix just magically suggests that exact show you end up binging all weekend? Or how your bank spots a fraudster and texts you about a suspicious charge before you even realize your credit card is missing? Well, it might feel like magic, but it absolutely isn't. It's data mining. Today, we're going to explore exactly how data mining finds the hidden patterns operating just beneath the surface of our everyday lives.
Right, so how does Netflix know exactly what you want to watch next? The answer lies in the work of these high-tech digital detectives. You see, these algorithms aren't just guessing. They are constantly looking for hidden clues in an absolute ocean of raw information. Every single time you click, pause, search, or scroll, you're leaving behind a trail of evidence. And data mining, well, that's the science of putting that evidence together.
Okay, let's dive into this and take a quick look at our roadmap. We're going to start by searching for hidden patterns, then examine the raw material of data. Next, we'll cover preparing the digital clues, how patterns are discovered, and finally, the math behind the match.
Section 1. Searching for hidden patterns.
Before we can actually solve the case, we need to clarify what we're doing when we, quote-unquote, mine data. Because a lot of people confuse it with simple searching, but it's totally different from information retrieval. For example, if you go to Amazon.com and look up a specific book, you're just retrieving existing information. It's exactly like looking up a number in a physical phone book. Data mining, however, is about grouping those searches by context. Think about analyzing millions of search queries to differentiate between someone researching the Amazon rainforest versus someone shopping on Amazon.com. It's about uncovering these deep relationships that just aren't obvious at first glance.
So, formally speaking, data mining is the process of searching, analyzing, and extracting useful information from large collections of raw data to identify hidden patterns and knowledge. The ultimate goal here isn't just to store information. It's transforming messy, raw data into really meaningful knowledge that drives better decisions, whether that means improving a marketing strategy or even predicting a disease in healthcare.
Section 2. The raw material of data.
Now that we know what we're looking for, let's look at the actual clues left behind at our digital crime scene. These are the foundational building blocks where the patterns actually hide. Our digital clues generally come in a few specific forms. First up, nominal data. These are qualitative labels without any numerical meaning or ranking. Think colors on a palette, or your nationality. Then we have ordinal data, which has a distinct order to it, like survey responses ranging from strongly disagree all the way to strongly agree. Next is interval data, where the numerical differences actually matter, but there's no true zero point, like temperature in Celsius. And finally, ratio data, which has all the properties of an interval, but it includes a true zero, allowing us to calculate precise quantitative ratios, things like annual sales or driving speed. Every single piece of data fits into one of these buckets.
Section 3. Preparing the digital clues. All right, so we've got our raw materials collected, but any good detective will tell you that you literally cannot solve a case with a contaminated crime scene. To get to the truth, we have to follow 4 strict stages in the data mining process. Stage 1 is data preprocessing, getting the data clean, validated, and properly formatted. Stage 2 is exploratory data analysis, where we kind of poke around to find initial relationships or weird outliers. Stage 3 is data selection, where we cherry-pick only the most relevant data sources for our specific goal. And finally, Stage 4 is knowledge discovery, where we actually extract that final golden nugget of useful knowledge so we can make a decision.
Now, what's really interesting about this is that these complex-sounding pre-processing techniques, things like aggregation, dimensionality reduction, or discretization, they are essentially just forensic methods to clean up the data so that true pattern emerges. For example, discretization takes continuous ages and groups them into clean little intervals like teen or adult. Dimensionality reduction trims away all the extra noise so our algorithms can run faster. It's really all about clearing the static so we can clearly see the signal.
Section 4. How patterns are discovered.
With a beautifully clean digital crime scene, we can now break our investigative tools into 2 distinct buckets. First, we have predictive methods. These are the tools that try to guess what happens next, or figure out a totally unknown value. Then, we have descriptive methods. These don't predict the future. Instead, their job is to explain what is happening right now within the existing data patterns.
Let's look at a predictive tool first, classification. This technique assigns data into predefined classes using labeled data. Just think of your email inbox. The classic spam filter uses classification as a predictive technique. It looks at the characteristics of an incoming email and predictively assigns it into a bucket that was already defined in advance, spam or not spam.
Now contrast that with a descriptive tool, like clustering. Clustering groups similar data points together, but it does this entirely without any predefined labels. It basically just looks at a massive pile of information and finds natural groupings based solely on similarity. It doesn't know what the groups are called beforehand, it just knows, mathematically, that these specific items belong closely together.
And beyond clustering, we have specific pattern discoveries that look deeply at human behavior. Association rules uncover relationship patterns, like noticing that a customer buying bread is highly likely to also buy milk. It's discovering how items associate together. Sequential patterns, on the other hand, look at the timing of actions. If someone buys a DVD player, well, they will naturally buy a DVD next. Or noticing that candy sales naturally spike right before Halloween. It's all about uncovering how one action naturally leads to another across a timeline.
So the crucial point is, how does this all differ from machine learning? Because the two get confused constantly. Data mining's core action is extracting information from existing data to discover hidden knowledge. And to do that well, it requires a much stronger foundation of domain knowledge. Machine learning, on the flip side, learns patterns from training data with the ultimate goal of prediction and learning without explicit programming. Simply put, data mining extracts the hidden knowledge, machine learning trains the system.
Section 5. The math behind the match.
Okay, it is time to enter the forensic lab and see exactly how these algorithms mathematically prove that two pieces of data are connected. To prove a match, we use distance measures. This is literally the forensic science of data. Algorithms calculate similarity using very specific formulas. The Minkowski distance is a general metric. Manhattan measures grid-like city block paths. Euclidean calculates direct straight-line distances. And Chebyshev measures maximum absolute differences. I know, it sounds incredibly complex, but ultimately it is just math measuring the exact distance between digital clues.
And this brilliantly illustrates how this math translates into a real pattern. Consider the number 0.767. This comes from an example of cosine similarity, which basically measures the angle between vectors. If we have a data vector A representing certain values at 3, 4, 5, and a vector B at 1, 0, 6, the algorithm calculates their cosine similarity and spits out 0.767. In this system, a score closer to 1 means the items are highly similar. So this mathematical score actually proves that these two seemingly random sets of data are remarkably similar and part of a hidden pattern.
Which leaves us with a truly fascinating and honestly slightly intimidating thought. We've seen how these algorithms clean data, group it, and use advanced math to calculate precise similarities. So if algorithms can already predict what we're going to buy, what we'll watch, and what we'll do based on these hidden patterns, what undiscovered knowledge is currently hiding in your personal data? I really hope this explainer has opened your eyes to the invisible trails we leave behind every single day. Thanks so much for learning with me.